how to make this really complicated. So hopefully this will be helpful. So just before I get started, who's employed plugins before or used plugins in an application? Okay. Who's used LabVIEW classes for plugins? Okay, so about the same people. All right, and who's tried to dynamically dispatch classes within LabVIEW pack libraries?
All right.
So that's exactly what I was hoping, because if everyone's like, oh yeah, I've done that before, then this isn't really that big a deal. It's not that fancy, but it's tricky when you get to the point of you have a class, you put it in a library, a LabVIEW library, that's fine. But then you put it in a pack library, and then you inherit to the version to that one in the pack library, and then you make all your other code inherit to that, and make that process work, and make a process that you can just deploy right through, develop. It gets pretty messy. I've learned a lot of things the hard way.
There's a lot of talk about this on the forums and in the communities. I mean, this is a pretty hot topic.
Yeah. So let's see what else. Okay, so just who's used pack libraries, and who uses them, and who likes them? Okay.
Who distributes their code to people?
I mean, I've also kind of had a feeling that some people like them and some people just say, you know what, forget this. This is too much trouble. So for whatever reason.
So what is a pack library?
What is a pack library? Yeah. So good question. A pack library is. Do you know what a LabVIEW library is? Okay, and LabVIEw library is just a container. It's like a class where it's just it's like an XML file that just says here's all the VIs that are in this library, right? A pack library is saying I'm going to take everything that's in that library, put it into a binary file that's pre-compiled, and you cannot mess with it. It's basically like an executable. So the difference being that if you build it with diagrams, then you can see the diagrams, you can debug it to a certain extent, which is really nice. And because an executable, you can't really do that very easily. There's ways around it. You can do some stuff to debug executables, but the pack library is kind of inherently just LabVIEW code, but it's all pre-compiled. You can't mess with it. And
it's basically like a DLL that only LabVIEw can call.
Okay.
Yeah. That's a good way to say it.
For testing.
So this presentation is going to go over the examples, like I said, dynamically dispatching LabVIEW classes within pack libraries. Maybe just a little quick on where to use plugin architecture, because I think it's kind of a niche thing. It's not really something you use all the time. I'll go through the demonstration first. I thought about going over all these slides first, but I thought, you know what would be better is just go over the demonstration. Then it'll give context to all the slides. I think that'll be better than speaking abstractly. So then I'll go over the build and deployment process, which is the most important thing. That's of all this stuff. That's the key. And then why use LabVIEW pack libraries, pros and cons, and then common pitfalls. So I think plugins are useful. First of all, when you have a stable application that needs extensibility. Stable is the most important word there. If it's not stable, then don't use plugins. Just figure it out what you need to do, keep developing, and then think about plugins later. But it's not a good thing to start out with, hey, I'm going to write this crazy application. I don't know really what it's going to do, but it's going to have plugins. That's not a good idea. Plan to extend, if you have a plan to extend functions of the stable application. So just because you have a stable application doesn't mean you need to use plugins, because you have to have a plan that in the future you're going to extend the functionality of this application. An example of that is I wrote a vector generator tool, and all it does is convert text files from A to B. And there was some file formats that I knew of today, but tomorrow I might have 10 more file formats that I want to do, and I don't know what those are yet because that's the future. But I don't want to have to redevelop a tool. I don't have to redeploy a tool. I just want to have it there, and I drop in a plugin to a folder, and then that plugin's available to everybody. So that was my plan from the beginning, though. It wasn't like I knew everything I needed to do, and I'll just develop it. Because if you know all the functions you need to do, then you might as well just write an application with all those functions within it. But it's when you're planning on extending it, that's when I think it's good to use plugins. Because it does take a lot of effort to get to the plugin, to get to a stability. I guess if I say interfaces here, I didn't say anything. Yeah, a good software architecture with stable interface. So the stable interface is also really important. You cannot change your plugin interface. If you do, you just have to refactor everything. So just you have to spend the time to come up with a good interface. Interface meaning you know all the methods that the plugin needs to call, and you know the inputs and outputs. And you don't change that ever. You just keep that the same. And then a deployment process that does not need to disturb existing installs. So what that's talking about is, like I said, I have a tool. I want to install it on a bunch of computers, or I just want to let that install be out there, and I want to allow people to drop in plugins later without having to mess with. So let's just say you have users that don't care about the new plugins, then they don't have to download the latest ones, or they could just drop in the ones they care about and delete the ones they don't care about. That's kind of what that's getting at. And if it's also useful if you have a potential for other developers to design plugins. You can come up with templates, and I think you guys' examples of generating templates is a great idea, like Nate was talking about. And you could have a template for a plugin and say, here's a new plugin, all you need to do is fill this in, and you've got a good plugin. It's pretty cool. So I talked about that first example. The second example, I have a user interface that dynamically builds user interface menu based on plugins copied into a file directory. So it was an application that actually I just had it on the file menu. It had one of the menu items was plugins, and you drop it. It's empty by default, but what it does is as soon as you load the application, it looks in a file folder called plugins. Anything that's in there, it loads on that list, and now you can select that plugin. So now somebody could just drop in a new plugin, and it just shows up on the file menu, and I can click it, and then it just pops up that plugin user interface. It does whatever I want it to do. So it's all that was a way to extend functions and get to variables that were within the application using the plugins. So that was what I used that for. And I kind of look at hardware abstraction layer, measurement abstraction layer as kind of like a plugin. It's not really a plugin, but I use the exact same. Right now we're using the same exact technology and deployment process and pack libraries with classes and dynamically dispatching. Exactly the same for hardware abstraction layer as I do plugins. So to me, they're kind of the same as far as the architecture that I'm going to talk about. So this might be useful just to keep that in mind. So I'm going to go over this example here. So I came up with this, I'm calling it a parent interface class. It's the parent class, but it's an interface, it's the interface class, but it's also the parent. So I just put parent in the name so you can know which one was the parent and which one was the child. But the interface class being, this is what your calling application is going to use in its code. So it's going to use the parent interface and the method 1 and method 2. And the child plugins are not going to be called at all in your application. Those are going to be built into separate little plugins that are dynamically dispatched, and I can show a little bit how that's going to work. So I just have two methods. They don't really do anything. These ones don't do anything. And then these ones, all they have is they have just a pop-up that says what it is. So this is child plugin B LabVIEW library. It's part of the LabVIEW plugin B class method 1, and then the method 2 does the same thing. So now you know where they're coming from. So I have a slide to show how this all works, but I'm going to go over this quickly, the process of building it, and then you can see how it's all put together. So the first step is coming up with a build spec. This is how you get a packed library. You create a build spec and call it something, tell it where to put it, and then your source file is this LabVIEW library, the destinations, the settings, advanced. I enable debugging because you can get to the block diagrams. If you don't have this, then you don't get block diagrams. And why not get it? I don't know if there's that huge of a performance to hit, but I guess if you're also if you have an application where you don't want your user to know what the block diagrams look like or what's going on, or you want to password protect it, you can do that, but we don't really need that for what we're doing.
I think I remember a long time ago that debugging on was like on the order of 1%.
Well,
4%. Some, one
so
or
it's
two.
kind of like, whatever, I'll take it. Because
Yeah,
it's
somebody might
nice.
need that one or two.
Yeah, if you need
Yeah.
it, then disable it, but I just enable it. So I'm going to build this really quick. Now, this is the most important thing about this whole process, is where it builds to and how you link to it. So let me go back to here, plugin examples. So in this file structure, I've got a folder called builds, and I got a folder called library. And it just built this pack library into a folder called builds. You can call it whatever you want, but it's important to have the two. You need two folders. One is where your builds go. So I built the parent pack library into builds. Now I copy that into the library. You can make this automated if you have a post build step. You can make it automatically copy itself into the whatever. I've done that too, but it's not a big deal. Depends on how often you're building, and if you want an automated build, then you should do that. So now the key is I'm going to replace this parent right here. There it gets back.
You still have the OK dialog?
I don't think so. I don't know why it's not happening. Deployment process. You guys should be able to figure this out anyway. It's not that abstract. So I highlighted in purple the directories because that's really important here. This is your source code originally. So I had that parent interface class, and I have the child plugin A and plugin B, and then these are classes within the LabVIEW libraries. So this is like a UML, it's a package diagram, and then this is a class diagram. So they're both inheriting from the parent interface class. So the first step is you build it. I built the parent interface class into a pack library. It goes over to the builds folder. So now it's there. Then I copied it into the library folder. And now I have two. I have one in builds and one in library. Then within the project, you replace the parent interface LabVIEW library, not P, you replace it with the pack library. And what that automatically does is now your two child plugins are now inheriting from the class that's within the pack library, within the live folder. That's the important part. So then you save everything. Actually, you don't really have to save it, but you probably should save it. And then build the child plugins. Now the child plugins get built into a pack library, and they go to builds. And so does your parent. Actually, what it does is it copies what's in here, because this is a dependency now. So when you build a pack library, or when you build this LabVIEW library into a pack library, it's going to also copy all of its dependencies with it. So it's going to copy this pack library. It's going to move that over there to the build, and it's there anyway, but it's just going to, let's say you deleted it, it would actually move it over there, and then it would create this pack library. Now this class in here is inheriting from that one that's in the builds. So, tricky.
When you're done, do you have to keep the one in lib?
No. Sort of. Maybe. Depends on what you want to do.
So what do you hand to your end users?
What you hand to your end user is what's in build. They could care less about source, right? You're wanting to build something, and then what you use is you use the stuff that's in build, and now I go make an application with it.
Right.
And what I use well, then it doesn't matter where it is, because now it just matters where I'm copying it to. So I'm copying it to my application, and I'm calling the functions that are all out of the parent interface, and then dynamically dispatching these guys during runtime. That's how the plugin works. So the reason why you have to have the copy, you learn this the hard way, is let's say I just built it. I did step one. I built it. Now I relink and inherit the source over to the build one. So now they're linking up there. There's no one here. what's going to happen when we build is it's going to copy that to itself, to its own directory, and it's not going to like that. You're going to get an error. So, it just won't work.
And that was my question, is what is that issue? And that's the fundamental thing, even if it's not classes here.
Even if it's not classes.
Even if it's not classes, you cannot say, this is a source, and it's a pack project library, and it's a source for my other pack project library, and you want to build, and you can't copy over. Once it's a source, it can't be a source and a destination at the same time.
So this is not obvious. It just is not obvious how this has to work. It makes sense when you think about it, but it's just something that you have to think about. This is the easy way. There's a harder way that I found like about a year ago. Someone came up with this awesome idea to make a post-build step to delete the pack library. Like, I think it's a post-build step. So right before it builds this guy into a pack library, first of all, it copies all the code over there. Then it relinks everything. Then you delete that guy. And then you save this guy, and then it copies itself into the one that's in memory, where the one you just deleted, and it works. But it's just more complicated than it has to be. You know, this is easier. Just do this.
So you said you have to find that out. So does that imply that there's no documentation on this methodology? Or
No, there's no documentation.
No, there's not.
Why?
We got cutting edge stuff here, man.
So,
Okay, I'm just gonna say we're working on it for 2014.
So the plugin, the whole plugin architecture is pretty new, or?
Well, here's the thing. Plugin architecture, you don't need all this stuff. The plugin architecture is just saying, let's just throw out the LabVIEW pack libraries altogether. Let's just say you've got your LabVIEW libraries and you got a class within there. Actually, you don't even need the LabVIEW library, but might as well. Let's just say that you got that. You could distribute the parent interface LabVIEW library into another place, let's say at some destination. You could put it in LLB, or you could put it in just by its source form, and then you can distribute the children the same way, or all at the same time. You know, you can distribute all of them at the same time, and now you've got everything. But what you lack in that is kind of a decoupling, or even if you did have the decoupling, now you've got source code out there. Right? So somebody can go into your plugins folder, open up your VI, mess with it, and then, hey, this plugin's not working. I don't understand why. It's because they mess with it. So the pack library is one of the, I'll just go over that. That's one of the pros and cons here. The pros for using the pack library is, it's a single binary file that cannot be modified, and it's easily distributed. That's really funny. It cannot be easily distributed. That's what it sounds like. It's easily distributed and it cannot be modified. That's two big benefits that I think outweigh the cons, but it's up to you and your application and how much you believe this is important. That number one. Another pro is that you've got the ability to debug the plugin if you build diagrams. I guess that's nice compared to like an executable, let's say, or a DLL. If you have a DLL, how are you going to debug a DLL? So. Password protection and hiding guidelines if necessary. So if you really wanted something, if you had a proprietary kind of plugin you don't want anybody to mess with, here's an easy way to do that. Aside from a DLL. So the cons are you have to have a solid build and deployment process. It's critical because you can see if you do that wrong, it's just not going to work, and you're going to learn the hard way like that is. The build process is not easy and cannot be automated in all scenarios. That's something I'd like to ask a question to the community is, do you know of any way to automate, let me see if LabVIEW's back up. It's easier to describe it.
While he's doing that, I'd also mention that one of the original motivators for packed project libraries is faster load time. Because when LabVIEW is loading, it only has to read from disk once, and it reads all the VIs in that library all at once. As opposed to a not packed library, it's going to read each VI individually, which is on different places on the disk. So it's supposed to make your application load faster if you use packed libraries.
Yeah, and it's precompiled, right? So precompiled code is it's up and going. Actually, it doesn't. It's not that fast, but.
Do you use separate compiled code in your source?
Do do I use what?
Do you use separate compiled code in your source?
Separate, like with
That
sub-VIs and stuff?
checkbox?
No.
I don't think so. Doesn't it complicate?
Yeah, that's just more complicated than it has to be. Well, from what I'm doing. Do you know a way, so let me show you the process. I'll go through the process here. I have the plugin in the builds folder here. And I'm going to copy that into the library folder here. There was already one there, but so now I'm going to right click here and say replace with packed library. Has anybody used this function? It's really nice. It's super easy. I just say replace with the packed library, select it, and oops. And then I go to builds and use this one, right? No, not that one.
Can you do
This
more?
one, library.
Yeah.
Don't do the wrong one. Okay, so if I look at the file menu, I'm linking out the one from the library. Because the reason why is that the child plugins are going to the builds directory, and you can't link to the one that's in the builds directory, right? So now I can build these two child plugins.
So their build specs already say point to the build directory
Yeah, so they go,
to get their source files?
well, okay,
It points to the library.
so the source file is that library. The destination is going to be builds, right? And it's automatically going to pull in all its dependencies.
Right.
Because it's an inheritance, it's a dependency.
Right.
And so
How do you know
gonna-
that it's not actually pulling the parent class into the child packed project library?
Because it's calling it out of a packed library. So you cannot. So that's another thing about packed libraries is you can't use code. You can't drop a, like, let's just say I have a new VI here. In my parent class, and I put this method down. This VI will not be used in whatever application I build this in. What it's going to do is it's going to pull the entire library, this parent interface LabVIEW packed library, put it wherever you just built it. It's going to, the whole thing is coming with it. Whether you use one VI or all of them, it's going to pull the whole thing with it.
I understand that, but you just said that when you build a packed project library, that includes all of its dependencies. And I agree with that, which is why I don't understand how this is preventing it from pulling in a copy of the parent class into the children's packed project library builds.
Because it's just LabVIEW it's not designed to work like that.
That's a really good question, though, and
Actually,
I have a similar question that goes with that in the comments, because if I don't create packed project libraries, and I can just, when I'm building my class, if I'm going to create a build specification, a source build specification for child, then I will exclude the parent
Okay.
from the build specification.
Okay.
And so the parent gets excluded,
Yeah.
and so the parent, I think when I did it, the parent just stays in the EXE. So I'm not having this issue of having to copy the parent or anything like that. And it's not, right, so I'm specifically excluding it. So I think that's the issue here, as
Yeah.
I'm thinking through this, is we don't have that ability with packed project libraries to exclude.
Yeah, you don't. You just
Yeah.
it will always copy it with it. You don't have a choice.
But Nate brings up a really good point, is if I'm not excluding it, how does LabVIEW know to actually just go create a copy and move it into builds as opposed to
Pulling it in.
Yeah.
It's designed that way.
Yeah.
But that for this scenario that works to your benefit because it's a plugin. So you don't want to pull in the parent.
Right.
No, obviously
Because
I
if
don't.
you pull the parent in there,
Yeah.
you can't then plugin B doesn't know anything about the parent that you just included in your plugin A.
Right, that's the fundamental
So
problem.
then your inheritance doesn't work, right? So I'm going to just show you one more thing.
A quick question.
Yeah.
So you right click and replace the
Yeah.
source code
Yeah.
version with the packed library version. Can you right click and put it back to the source code
Ah!
version?
That's what I asked. That's what we need. We really need that.
So you can't?
There is no way to do that.
That would be
So the way
frustrating
you
if
do that is you go What's that?
That'd be frustrating if you have to debug.
Oh, yeah. So you can debug with the packed library. I can open this right now. This is the packed version, but I can't edit it. You see, it's kind of locked. And I can see the block diagram, and I can even highlight the execution and everything. The only thing that's annoying is in a packed library, when you probe on a class, it doesn't give you all the class properties. It just says, hey, it's this class. And that's not really helpful, right? So you have to build a custom probe. One thing you can do is build a custom probe which basically means you have to create a VI that shows all your properties that you care about, and then include that in your pack library, and then build a custom probe with the one from your pack library. So it's a lot of trouble, but yeah, I mean, I've done that before, but what's more practical is just keep diving down into the sub VI until you get to the data you care about, then you can probe on it. And as opposed to getting to the properties themselves. That's good enough for a lot of scenarios.
So can you show us your build folder?
Yeah, let me show you something. Nothing up my sleeve, right? This is the builds folder. I'm going to build the 2 child plugins, just so you believe me what's happening here. It copies the parent, and then it copies, and then it builds the child plugins in there. So now you get all 3. So now this is what you care about.
When you say when it copies the parent, that's not a separate.
This is
to
part
clarify,
of the
it's
build.
just part of the build specification.
Just you build a LabVIEW library, it's going to copy whatever dependency.
All of its dependencies go in there.
Going to go in there. Yeah.
But the parent was already a packed library.
Yes, it was. That's why it got copied. If it wasn't a packed library, if it was just regular VIs or in a LabVIEW library, then it would get copied into the child.
So when you say dependencies, you really mean all dependencies except for packed libraries? I thought packed libraries could contain other packed libraries.
No, they can't.
Okay.
What they do is it just copies it.
They're already packed.
Yeah, so that's one
Okay.
one thing to understand. And it kind of would be nice if you had the option, because I've had scenarios where I've had a packed library and I don't want to have to move. Now you got to move around 2 packed libraries every day. So let's say you have a reuse library, it's in a packed library, and you use it, right? And I have this code over here. And when I build this code, it's going to copy that guy with it. So now you got 2 things I got to manage, as opposed to just building it all into one executable.
You realize you gain something by doing that.
You do gain something.
That parent could be replaced
Yep.
in 5 minutes. The
Yeah.
code would work differently,
Yeah.
and you wouldn't have to rebuild the pack library.
Yeah,
as hauling it.
it's pretty awesome. I think it's
So
great for.
that's the advantage, because now you can change the behavior by pulling out one of those pack libraries and replacing it. Nothing else has to be compiled, it'll all still run, but you just put a new version of the parent in there.
So
With a
In
caveat.
this application, that doesn't make any sense.
With the
but if you're doing other
caveat, if you
things, it
change
does.
anything in the parent that
Right.
causes a recompile, then you're screwed.
Yeah, well, you won't even be able to run that.
Right.
So, we discussed the building, the packaging of these pack libraries. Are you gonna get into deployment, or just simply copy it to, wherever your application is deployed into some social?
Yeah, let me show you deployment.
Is that simple?
So I have an example application here. It's really simple. I'll open the, oh yeah, okay, I can't find the plugins. Wonder why, because I deleted them. So I have the builds here, those 3 plugins, the parent interface and the 2 child plugins. I'm going to copy that into the plugins folder here. And I'm going to open this application. And here's my example application. It's very simple. Let me just show you. This is the parent interface pack library, the method 1 from that class. So it does nothing. So if I run this, it just does nothing. And then the other thing I have in here is selecting the plugin. So these 2 guys together, you can get the path to the pack library. Actually, what you need to get is the path to the class within the pack library. You got to use this function. Well, that's the easiest way.
where did that function come from?
I don't know. It's a good question. In the pack library.
Oh, okay. That's what I recognize it.
I don't know. I couldn't remember either. And I had to go back to my application and I'm like, where did I get that? I don't remember. And then there's this guy that you get the. Have you guys used this before? You get the default class by path, and then what you have is you have you're typecasting it to the parent.
So since you've already statically linked, you've already made a connection between your VI and the parent object by putting that class
Yeah,
constant
yeah.
on there. Is there really a benefit of having that dynamic path to the parent?
Well, this isn't a dynamic path to the parent, this is a dynamic path to the plugin. It's the path to, actually I lied, this is that one.
Yeah.
It's just for demo's sake. So here's your plugin A, pack library, and then here's the class within that pack library.
Well, I guess my point was you can't distribute this VI without distributing the parent, because it would say I can't find that constant right there.
Right, so don't use a constant. I just use a constant for the
For the casting, for the plugin architecture.
yeah, this right here, this constant right here.
No, the object.
Oh, this guy, yeah. No, you have to have a parent. This is your interface, and that goes with your application.
So why not distribute it with the application as opposed to making it a packed plugin?
Oh, no, the parent was.
Oh, that's a good question.
That is a good question.
That's a good point. Actually, you know what? That did come up in a code review that I had. You know, he's saying, well, why don't you just build not a pack library? Why don't you just have the library itself built in with the application? I think it gets a little bit hairy if you have to build your application and then relink your child classes to the one that's in the application.
So it's to simplify the build process.
It's going to simplify a little bit and to decouple it. Probably just easier this way. I don't know.
So, but this means that you would have a copy. So if you built this VI into an executable, that executable would absolutely have a copy of that parent class inside of that executable.
Yeah. Well, actually, here's the thing though. Executables don't include the pack library either. Nothing includes the pack. It's like they're insoluble. You know, like you try to like put them in water and they just stay there. You know.
They get included in the data folder or something like
Yeah, it
that.
gets included in the data folder or wherever you tell it to.
Right.
So when I've built an application using this interface, I'd say move this guy or put this guy into a plugins folder, and it's important to get to have the parent in the same directory as your plugins. The reason why I've done it before otherwise, where I had this in a data folder and then I had the plugins in a plugins folder, because I was too lazy and I didn't want to filter that. I just wanted to say everything in this folder shows up on a drop-down list dynamically.
Right.
But what happens is it takes forever to load because although you have the parent in memory, it's not in the place where that plugin thinks it's going to be. The plugin thinks it's going to be right next to it, but it's actually over here. And every time I was selecting it, I was like, gosh, this takes forever, and this is really lame. But I just found out that was why. And so I just made my application a little bit smarter and filter out the parent because I don't care about that one. What my application did was I take everything that's in the plugins folder, anything that you drop in here, dynamically build the list that's on this front panel right here. So right now it's static, and I have it here for the demo. But this list should be built dynamically.
Yeah.
And whenever you load up, you say, show me everything that's in the plugins list. And then I dynamically build this by name. This is just the name, and then this is the name. So you can dynamically do this so that when you run this, if I say go, that's the parent plugin, it's doing nothing. If I select plugin A, it says it's calling plugin A method 1, and then plugin B, it's calling plugin B. So now I can distribute this, and I can add a plugin C, and you know, if it's dynamically shows up in the list, it'll just run. So that's kind of the idea here. Application. Any other questions? Let's see.
You were gonna show us how you put it back.
Oh yeah. That reminds me. Thank you for bringing that up. So it was really easy to say right-click, replace with pack library. Now I want to go back. Oh, that's a pain in the butt because I have to basically add the original file. There's no way. The short answer is there's no easy way to go back. I get the class library, and then I say find all the places where this is used. And let's say these methods are called. These methods 1 and 2 are called within here, or you have some lower level private methods that are called. Now you gotta replace each of those individually.
Eesh.
And then you gotta go, and you gotta say in here, go back and inherit, because it allowed you to automatically change your inheritance from the one that's it inherited to the one in the PAX library, right here. Where'd it go?
There it is.
Yeah, so you have to inherit from, this is the one that's the PAX library. You have to now change it to this one. Did you get the right one? So anyway, you have to go back, and it takes a long time, and it'd be awesome if you had a feature that said, you right click this and say, go back to a LabVIEW library instead of from a PAC library. Just, that'd be great. So, along with that,
Or you don't save your project after you reassociate it to the
okay,
tax.
so that's the other thing. No,
Don't save!
Don't say, that's actually what I do. So this is not ideal, and I kind of have, I'm not uneasy about this, but my build spec right now, in one of my, it's for one of my hardware abstraction layers, the build spec is, see, I'll go back and I'll update all the code, discard everything I just did, and now reload my code and go back to before I relinked it.
Mm-hmm.
So part of my build spec is to go in here, build the parent, relink to the parent, and then build the plugins. That's not ideal, because that's not, as far as I know, this is the question I have for the community is, do you know of any way to to actually call this replace with the PAC library feature? I haven't seen it.
Yeah.
I tried to like a method that's in the for part of the project. I enabled the super secret functions, maybe thinking it was there. No, it's not there either. I didn't see anywhere where you could dynamically replace a PAC with a PAC library. So with that being said, that process cannot be automated if you can't do that, right? So not necessarily ideal. It's a very manual thing. You got to tell. Part of my build spec is come in here, build the parent first, replace with the PAC library, then copy that guy from the builds to the live, then relink to the one in the live, and then build the children. So that's a really painful build spec.
By build spec, you mean written build
Oh yeah,
instruction
like
procedure.
A build procedure. I should probably call this
Yeah,
procedure.
right. Build spec has a connotation there.
Okay, build procedure. So that's not ideal. Now the other thing you can do is you can save your source code linked to the packed library. The problem is like I said, like I showed you, if you want to go back to the LabVIEW, it's a painful process. So what I have in my suggestion here is common pit files. Do not replace LabVIEW library with the LabVIEW packed libraries in the source code until the software is stable. So I was doing a lot of development, making sure everything's right, going back to the parent, messing with the parent, going to the plugins, messing with the plugins, going back and forth, until everything's really, really stable. Then maybe that's when you replace it with the packed library and then commit that code, and not before then, because you don't want to go back. I've done that.
So I have a question to the community, I guess. So, Nick gave a really good presentation on, creating a project wizard. And it might already exist, but is there the same thing for the back-end build wizards, where we could do some of this custom scripting that right now we can't do? I mean, is that part of?
You can automate build specs.
Yeah.
You can call the build, all the build specs in a project, you can call automatically through an execute, through a command line. So then you can use off-the-shelf tools like, what's the one?
Well, I was thinking more in terms of a wizard written in LabVIEW that could do some of these, manual processes you're having to do now.
Well, like I
And
said,
again, you can automate a lot of those steps
can
in the
automate
build, but he was
everything.
missing one. And who's that make it a pack library?
yeah. You can even automate the building the packed libraries. It's what you can't automate that I'm aware of is replacing
Yeah.
a LabVIEW library with a packed library as part of your automation. That's not going to work as automated. So what you probably want to do is commit your code to the one that's in the packed library, and then you can automate everything. That would work.
I'm wondering if maybe it's kind of good that we don't do that me just give a perspective here, and that is, if I'm putting together a library that you're gonna be using, and I go in and give you my pet project library, because I'm pretty sure we're there, you find 10 bugs, well, I still have that separate project that is dedicated only to debug and test at my pack project library. So I go back and do my debug, blah, 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 and then I just send you the new pack project library.
Yeah. So yeah, exactly. It's not that bad. It's just depends on how you're maintaining the code. If you yourself are doing all this, it's kind of more. I found it's more easy to not commit the code, relink to the pack library, just because it's easier for you to go back to the source. But if you're kind of distributing this, or you're having multiple people develop the plugins and stuff, it's probably better just to commit it that way. The key word though is stable. That's the key. That's the key. Get it stable. Get the interface so you just know it's never going to change. And that's hard. That's hard to get to that.
That's part of the part that I like about that is when I give you my pack project libraries, you can't change it.
Yeah, I know. Well, that's it's like a double-edged sword, right?
Yeah,
It's
exactly.
a benefit and it's also a pain too.
Yeah.
So another pitfall is your calling application cannot link to the parent interface library in the build destination. I talked about that, right? Where you got to copy it. Okay. Parent interface library should be in the same directory as the plugins when deployed. Otherwise, the software load time can be very long. I talked about that as well. It'll find it. It's in memory, but it's just not where I expected it to be, so it just takes forever to load. So just keep it. Just plan on all your pack libraries being in the same place. Now, there's another issue that with pack libraries regarding that is if you have application 1 that's using a bunch of reusable pack libraries, and you have application 2 using the same reusable pack libraries. Now you got to copy those on a disk, and that could be dangerous as well because you could be cross-linking. So there's some stuff you got to think about and worry about with respect to that. That's just pack libraries. That's nothing with plugins. And then make sure you keep track of the right build artifacts. You could potentially really mess yourself up is if you went to the library and you forgot to copy, or you copied some of the plugins but you didn't copy that one, and it could be a mess. You just got to have a very solid build process. You could accidentally use the put the wrong one and put it up to your artifactory or whatever you use to store your artifacts, and potentially use them, because now you have duplicates. You have copies on your hard drive of the different plugins. And if you automate your process, then you don't really have to worry about that much. But that's if you automate. So
I'm gonna make one comment. I think bullet 2 with regards to the copy, I think that goes away in 2014 because we are improving a couple of key things with pack project libraries. So if you really care about this and it's important, let me know so I can kind of keep you in the loop.
So that's pretty much all I had. I'm right out of time, but I have an example of the actual tool that uses plugins. If you're interested in seeing it, I can show. So, any questions? Any other questions?
My brain hurts.
Your brain hurts. Yeah.
So who was the target audience for those bills at the final flowchart,
Yeah.
terminals? And are they kept as VIs or are they executables?
These ones, right?
Yep,
Those are pack libraries.
right,
They're not VIs and they're not executables.
okay.
They're pack libraries.
But what's inside them? Are they used by developers?
They could be. Well, in this scenario, for this context, I'm talking about plugins.
Okay.
So plugins being, I drop this little thing in this folder, and all of a sudden my application has extended features, extended things. So another scenario is like I was talking about the hardware abstraction layer, where we're using this pack library for a DMM, this specific DMM, and then another one for another DMM, and we're swapping those out. So in that scenario, you're probably using the VIs within them directly, right?
So a developer down the road is going to create another plugin of one of those blue screens.
Yeah, they're going to create one of these,
And then
perhaps.
still do it.
Yeah.
So a dumb question, what's it look like if somebody gave me a pack project library today? Because I've never seen one.
Oh, really?
What do I see if I just double click the file? Does it look like a LabVIEW project?
It's pretty cool, actually. I really like them. They're you open it and it looks like this, And here's the PAC library, here's the class in that. If there was VIs, it would just be underneath here. And then I can open method 1, and there it is.
So it's a library,
And
it's a library
private methods
navigator.
are hidden, that's the key thing.
Oh, cool, not
Yeah.
even shown.
You do
They're not
not
even shown.
see the
Yeah.
private stuff at all.
Nice.
Yeah.
Suggest you put that down, the child down on the sub VI to show them.
Yeah,
Oh,
yeah,
it's
you
just
just
like a
drag it
VI.
out of
Yeah, it's just
there
like a
into
VI.
It's
the.
just a
Yeah.
function.
There's nothing too fancy about it. I mean, it looks just
Okay.
like that. The only difference is you can't edit it. You go in here and I try to mess with it and I can't. And then, you know,
Is it-
when I create a constant here, what this is it's the show class library. It's the PAC library, and it shows up just like it looks just like a Laffy library, except it has a little lock on it.
Right. So how can you tell from a VI whether it's part of the PAC project library, other than that you can't edit it?
The main thing is the name, the P on the end of that PAC library, and it's locked.
Gotcha, but from the method 1 VI, does
Yeah.
it give you its fully qualified namespace?
Yeah.
Like from that diagram. Yeah,
This
you
is
just
the
have to
name.
open
This
it.
is actually the name right here.
Aha.
It adds a
Okay.
P on it. So
Okay.
that's one thing you gotta maintain. And the class, and then it has the method, and then it's pretty straightforward.
Oh, Philip,
Yeah.
do you have, I know the example you were referring to, I believe was Michael Lacasa's online example.
Yeah.
Do you, and I think he was putting them in libraries first, and then, so if you looked at it on disk or the hierarchy, it was like library, then PACS library. It doesn't look like you're doing that.
No.
Did you
I've done
care
it that
either way, or?
I've done it that way that he did it, and it's just more of a pain. Now you gotta do this post build step, and it takes longer too.
Okay, so it's just like another layer of.
Yeah. The downside to my way is that you've got to duplicate your stuff from here and go over to the from the builds and go to the library, and that's not ideal either, right? You don't. Duplication's never a good thing, especially. Not just more opportunity for error, but it's easier. So, okay. Yeah. Any other questions? All right.
Cool, thank you.
Thank you.